So here we are for the IS number 21 notes part 2. We're about to do the do step. So we are going to go to analysis, hypothesis testing, and mean of two independent samples. Oops, sorry guys. Okay, so up at the top, again, this is just the home page. I have this data entered here, ignore it, it's not important. We're gonna go to analysis, choose hypothesis testing this time, and then mean of two independent samples. Again, we have the option to use summary statistics or use data. This time, the context of our problem did not give us all the individual data. It just gave us the summary statistics that I wrote out over here. So that's what we're going to use. And I'm going to be looking at this as I type this in. So notice it's asked in this order. In sample size, sample mean, standard deviation for the first sample. Sample size, sample mean, sample standard deviation for the second sample. So that's just what I'm typing in here. Actually, the very first thing, I guess, is the significance level, which we decided was 0.05. So I'm going to change my sample size for the first one to be 30. And then I have 225 as the sample mean, and 100 is the sample standard deviation for the first one. Now, I don't know the population standard deviation, so I'm going to skip that. Second sample size is 40, and then 265 is the second sample mean, and 75 is the second sample standard deviation. The only other thing I have to remember to change up here, and this is really important, is my alternative hypothesis. So notice this is assuming the null is that the difference is equal to 0. So the alternative is the only thing that can change. So it says the population mean for number 1 is not equal to population mean number 2. That's the first one it starts out on. That is not ours. Remember, we are using that the first population mean is less than the second population mean, which we rewrote as the difference being less than 0. So this is kind of what we're looking at for choosing this up here. We want the bottom one, population mean 1 is less than population mean 2. So we select that and then we hit evaluate. Again, this method of analysis, we're just going to always leave it on unequal variances. We're not going to mess with the other stuff. Evaluate. All right, so we have all this information. It reminds us of what our alternative hypothesis is. Check and make sure that that matches what we have before you move on. It does. So we can write down our test statistic and our p-value. Okay. All right. So our test statistic is t is equal to, wait, I'm in the wrong spot. T is equal to negative 1.83734, and my p-value is 0.03, oops, sorry, you can't see that, 0.03595. Okay, just copying that from that computer output again here. So one of the reasons we didn't just start using these computer outputs from the very beginning is that we have to understand what the p-value represents and how we interpret it. So remember, this is the probability of getting sample results like the ones we got purely by chance, assuming the null is true. Now, that's a really low probability. It's less than our significance level. So we're convinced that it wouldn't happen just by chance if that is true, meaning this must not be true. Our alternative hypothesis must be true, or at least we have convincing evidence of that. So our conclusion is that since our p-value equal to 0.03, I'm going to round to 6, right? I don't have to write out that whole thing, is less than alpha equal to 0.05. All right, whenever the p-value is less than alpha, we reject the null. Right? It's so small that we're convinced that null must not be true. We reject the null, okay? Which means we have convincing evidence. We do have convincing evidence. And I'm kind of going to go back up to the problem statement again here. We do have convincing evidence that the average calories per receipt at Starbucks with a labeled menu is less than at a Starbucks without labeled menus. I'm just gonna write that down. That matches my alternative, right? It matches that the first population mean is less than the second population mean. So we do have convincing evidence that and instead of saying average, I'm gonna say the true mean. The true mean calories per receipt at Starbucks with labeled menus I should say with a labeled menu, is less than at a Starbucks without labeled menus, or without a labeled menu. Okay, that's it. That's my conclusion. So the last thing here is just the big ideas for section 9-3, inference for a difference in means for two independent samples. We haven't specifically talked about this word inference, although it comes up in your textbook a lot. Essentially, it's the confidence intervals and hypothesis tests. So we learned two new procedures. We learned the two sample t interval for mu1 minus mu2 and the two sample t-test for mu1 minus mu2. I do want to mention the conditions. They are the same as they have been, the random 10% and normal condition. But remember, whenever you have an experiment, you don't have to check that 10% condition because they're not random samples, they're randomized treatments. You are going to use statdisc.org in order to actually complete the intervals and the tests. And on your exam, you will be given that StatDisc output. So the really important part is that you know how to read that output. Okay. And then in your conclusion, I really want to remind you that whenever you conclude, you need to be sure to use context. And again, go back up to the original problem statement and use that context. Make sure that you're including it. Okay, we're going to move on to the next part in the next video.